AOML has been instrumental in improving our monitoring, understanding, and prediction of tropical cyclones and ocean phenomena, as well as their broader impacts on extreme events and associated hazards. We do this in three ways: by creating an integrated view of hurricanes, by making our observations count, and by modeling hurricanes above and below. Our scientists at AOML collect and evaluate real-time atmospheric and oceanic data within and around hurricanes to provide invaluable insights into their behavior and impacts. Our primary way we do this is by supporting NOAA's Hurricane Hunter missions. When flying into hurricanes, we strategically use our resources to maximize the effectiveness of our data collection efforts. We employ an array of advanced instruments to gather data from inside hurricanes in a way that is not possible from satellites and ground-based sensing. Remote sensing instruments such as the tail Doppler radar can scan large areas of a hurricane, while in situ instruments like dropsondes directly measure smaller regions. More recently, we've launched drones from our crewed aircraft to collect data in areas that are too dangerous for traditional flights. We also gather in situ data in our oceans beneath hurricanes. For example, sail drones and gliders observe conditions at the atmosphere-ocean boundary layer and coordinate with instruments such as Argo floats to paint a complete picture of ocean conditions up to 2,000 meters beneath the storm. Observing hurricanes with multiple instruments simultaneously provides many lenses to evaluate the current state and evolution of these storms. AOML has also been vital to real-time transmission of atmospheric and oceanic data to operational centers. This effort has provided essential information during critical moments, leading to improved forecasts and more timely warnings for our communities. In thinking about how to better observe hurricanes in the future, we are currently exploring how to use emerging technologies for collecting data, as well as how to optimize our sampling strategies. Beyond transmitting our data to operational centers, AOML also makes our observations count for our weather prediction models. Optimally using real-world data to improve forecasts requires advanced procedures to combine the observations with the model's best guess of the initial state of the atmosphere and ocean. We continually strive towards improving how the data is ingested into our weather models. Our next generation efforts are exploring how atmospheric and oceanic observations can be ingested together into our weather models. To further improve model forecasts, AOML also leads efforts to understand the value of different observing systems and to optimize sampling strategies. Our research has found that forecasts benefit most from using state-of-the-art techniques to ingest high-quality observational data with limited spatial and temporal gaps. These studies demonstrate that improving observational coverage of hurricanes could lead to even greater forecast improvements in the future. Making our observations count wouldn't be possible without advanced modeling systems that can reasonably reproduce the structure and dynamics of a hurricane. Over the past decade, our scientists at AOML have used observations gathered on the Hurricane Hunter missions to help advance many of the improvements in physics for operational numerical hurricane prediction models. Our next-generation modeling efforts are exploring how to effectively account for how hurricanes interact with other hurricanes, other atmospheric features, and the ocean. We are doing this with HAFS, the Hurricane Analysis and Forecast System, which was formally adopted as NOAA's new flagship forecast model in 2023. HAFS is built on the success of the Hurricane Weather Research and Forecasting Model, or HWRF, whose impressive performance left a lasting legacy on hurricane prediction. As we look to the future, we are currently exploring ways to better express uncertainty in model forecasts and will explore ways to incorporate AI into our modeling efforts. Collaboration with scientists at other labs, university, and the private sector, both nationally and internationally, enhances our capabilities and is instrumental to all of these efforts. By sharing best practices and technologies, we strengthen our collective ability to respond to hurricanes and improve forecasting accuracy. Through our combined efforts, AOML helps NOAA create a weather-ready nation by furthering our monitoring, understanding, and prediction of tropical cyclones and ocean phenomena, as well as their associated hazards such as wind gusts, flooding, and tornado outbreaks. We look forward to having you here to learn more about what we do.